Our concept based on the continuing exploration of the alternative space type of the NYU Bob's library atrium. In the section A, we are trying to use a roof that is divided by 30 by 30 grid and then attach them to the adaptive component modeling in the Revit. In the next phrase, we are trying to transform the 2D roof into a 3D form that occupies the whole interior atrium and the upper floors of the Bob's library. This alternative structure could bring into more natural light into the library and provide more interactive spaces to readers for reading, resting, and communicating. Inside the Bob's library atrium, the atrium is about 30 meters by 30 meters, and the height is about 50 meters. First, we are trying to give the atrium different heights of floors that people can go into the atrium. Instead of designing the whole atrium, we are looking at one special type that can be modeled inside this atrium. The first thing we are trying to do is to redefine the atrium of Bob's library by introducing different floors inside the atrium. Then, with the aim of increasing the communication between the readers, and providing different types of chatting and resting spaces, we define diverse types of bubbles onto each of the floor. After defining the shape of the atrium, the first step was to transform the polyline surfaces into meshes. Then the meshes was reconstructed according to the maximum and minimum edges to be then input into Kangaroo for shaping itself. One of the input of the Kangaroo settings was to define the anchor point of the meshes. There are actually two types of anchor point, closed points and naked points. Closed points were then to be adapted with the forces, while the naked points were tied with the position without changing its coordinates. With the assistance of the Kangaroo, the rectangular meshes was transformed because of the inner forces that different kinds of caved spaces are created. Inside, you cannot tell the differences between the wall and floor, that all of them has been integrated together. Because of the caved spaces, different kinds of vertical spaces are created. They also act like the column of the whole structure. Zooming in, we can see many triangle meshes. These triangle meshes lines are then to be utilized for the structure that support the whole system. By deconstructing each of the single triangle surfaces, we could get the data information of each of the surface, each containing 3 vertices, 3 lines, as well as the normal line. Then, by utilizing an artificial line, the artificial line is here, this line, representing the daylight, we could calculate each angle between the daylight artificial line and the triangle surface's normal line. After getting a list of the angles, we could remap them and link them with the color gradient. Red areas means more exposure to the sunlight, while dark areas means shadow. After getting the sunlight analysis, we utilize the 3 different kinds of strategies for the analysis. The first one is to link the sunlight analysis with adaptive panel. We want to link the color mapping analysis with the adaptive panel that the areas with more sunlight, more red, are linked with the adaptive panel of more opennesses. The logic is based on providing more comfortable spaces for readers inside this structure system. The second strategy is to changing the direction of the sunlight. Originally, it is this line. Right now, we want to change that. Because of the change of the sunlight, the whole daylight analysis has been changed. The reason behind changing the direction of the sunlight is due to the fact that the horizontal floor are areas where the readers could walk onto. There are the places where the adaptive panels should not have opennesses. Therefore, the artificial sunlight should be changed its direction. The third step was to managing the data tree. As the artificial sunlight direction has been changed, the angle between the triangle structure surfaces and the sunlight would be from 0 degree to 360 degree. Thus, in order to link the domain with the parameter of adaptable component, we utilize several if conditions in order to adjust the data tree and manage them to be linked with the core parameter. As you can see, the red areas means more sunlight, while the dark areas means that people can walk onto, and there is no opennesses of the component. So this is the analysis of the sunlight that can be linked with the adaptive component, and the left side is the whole structure system. So because of the use of kangaroo, we could totally transform the left side, that our definition of the atrium, to the right side, that this whole structure was linked together, that all the walls and the floors are integrated with each other to provide a new kind of experiences of reading for the readers in the Bob's library.
First, we want to create the structure of our components. So we make the 3 points as a relative point and connect them as a triangular shape. And then we create the midline of this triangular. So find the fixed points on each of the 3 midlines. And we create 6 host points on the corner points, and each of 2 relative to 1 corner point, and then connect them to make the thickness of this shape. Lock them so it's the frame of our component. And then we try to make a movable panels. First, we choose an edge and find the midpoint on that edge, and find another point to host on it, and then make the depth. So connect those 2 points create a line is perpendicular to this surface. And then we find the points align on this line. And also we separate this edge as 2 parts, and each part has its points align on it. For those 3 points, we both create the parameter as the same name, P0, and we also create a formula. So the formula says if P0 is smaller than 0.2, it's 0.01. If it's not, it's P0. Then we connect those points to the corner and we love them to create a panel. Then we try to run this formula. We change the P0 to smaller than 0.2, and then it says 0.01, and then we change it larger. So it's exactly the same as the P0. First, we try to upload this family into the project. So it appears here as the generic model family for type 4. And then we use the Hummingbird to write the folder path first as my documents Hummingbird. So it's my document Hummingbird points 2 as the CSV file name, and the family name is family 4, the type name is type 4, and the parameter name is P0, and it says complete successfully. So then we open the Revit, the Alice Hummingbird, and run it. Create elements from file. The folder CMS is the document Hummingbird. Point 2. Keep elements. Family type 4. Adaptive point type 4. Family 4. And then process. And after that, it appears like this. So this is our final model.